Hello students, in this video we are going to discuss 2.8 and 2.9 from chapter 2. In a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 power minus 3 meter square and the distance between the plates is 3 millimeter. Calculate the capacitance of the capacitor. If the capacitor is connected to 100 volt supply, what is the charge on each plate of the capacitor? Coming to calculate the capacitance of the capacitor. In the absence of the medium, the capacitance I am writing C0 is equal to epsilon naught A by D. Here epsilon naught value is 8.85 into 10 power minus 12. A is 6 into 10 power minus 3 divided by D value 3 millimeter, 3 into 10 power minus 3 meter. After simplification, we will get this value is nearly 1.8 into 10 power minus 11 farad. If you are writing it is in terms of pico, we can write 18 picofarad. This is the capacitance of a capacitor without any dielectric medium. If this capacitor is connected to 100 volt supply, what is the charge on each plate? So, the charge Q is equal to C into V. Here C0 into V. C0 is 1.8 into 10 power minus 11 and V is 100. So, this value will be 1.8 into 10 power minus 9 coulomb. This is the capacitance and charge in the absence of the medium. Why I am writing C0 and Q0 means this problem is linked with next adjacent problem. That's why I have taken like this. Coming to 2.9. Explain what would happen if the capacitor is given in exercise 2.8. A 3 millimeter thick mica sheet of dielectric constant 6 were inserted between the plates. Previous, the capacitance of the capacitor C0, we got it 1.8 into 10 power minus 11 farad or 18 picofarad. Now, this complete gap is filled with mica. Actually, its thickness is 3 millimeter and the thickness of the mica sheet also 3 millimeter. That means the gap between the plates is completely filled. Now, while here again two cases. While the voltage supply remains connected, we need to find out capacitance and charge. After the supply was disconnected, we have to. Now, first case, it remains connected. How much is there? 100 volt is there. In this case, definitely the capacitance in the case of medium is equal to K times of C0. In one of the video, we have discussed when the battery remains connected, when the battery was disconnected and a dielectric slab is introduced, how these factors vary. We did one video based on this. C in the case of medium is equal to K times of C0. This K value is number 6 into 1.8 into 10 power minus 11. So, this value will be nearly, you will get 10.8 into 10 power minus 11 farad. And what will happen to the charge? The charge in the case of medium is equal to K times of the charge in the free space. That is 6 into, and the Q naught was 1.8 into 10 power minus 9. This value again becomes 10.8 into 10 power minus 9 coulomb. Here, while coming to B, after the supply was disconnected, when the supply was disconnected, the charge remains same. Q here is equal to Q naught only, that is 1.8 into 10 power minus 9 coulomb. Capacitance in the case of medium becomes K times of C naught only, that is previous we did 10.8 into 10 power minus 11 farad. So when the battery is disconnected and battery remains connected, there is no change in the capacitance. While coming to voltage, when medium is introduced and battery is disconnected, it is nothing but V naught by K. Previous it was 100 by 6 is equal to 16.6 volt. So this is the potential difference between the plates of the capacitor. Thank you.